Hello, my name is Mohammed Bakhet and this is my demo for the crop yield prediction summative assignment. In this video, I'll walk you through my mobile app, my deployment configuration, and the machine learning model behind it. So I had already put the values here. This is my Flutter app. This is running completely native, taking in 6 specific features. I'll enter India for area. So India is already here. Let me put maize here or wheat. I'll put the year 2020 and I'll just put some data here. 1500 pesticides, 1000, and average temperature 27. So it securely passes when I press predict. It securely passes this directly to my deployed API and returns the expected yield in hectograms per hectare along with the confidence band. If you look at the Flutter code here in main.dart, you can see the make prediction method, which is here, and I use the HTTP package to serialize these inputs into a JSON payload and execute like a post request to my API and awaits the data. I'm also doing the client-side form validation to ensure no fields are empty. See the HTTP request here, and then also handling the response here. Swagger UI, the data type and ranges. Now let's look at the API directly from the Swagger UI documentation. The API takes exactly same variables. Notice that because I use pedantic base models, the data types are strictly enforced. For example, area is a string and rainfall is a float, for example here. So, and additionally, I've implemented range constraints. Let's test this. If I try to have like let's try it out here. If I like a negative number for rainfall or a year like 1800 here, let's see what it gives. The API rejects it directly. Let's execute here. You see, input should be greater or equals to. It gives an error here, 422. And if I say something, and if I execute here 1900, I execute, it gives me, okay, I have to put countries and everything. It gives a 200, like it returns a 200 okay with the yield if I put all the information here, just like I did in the app. So let's go to the model creation and the notebook explanation. Go back here, multivariate, yes. So moving over to the notebook, this model focuses on predicting crop yields using volume and variety rich data. I trained like 3 models, and which are here: decision tree, random forest, and linear regression. Based on a dataset and non-linear relationship between things like pesticides, temperature, and yield, the random forest dramatically outperformed the others, with the lowest loss metric holding the tightest fit to the test data. I saved this model using joblib to host on the API, as you can see here. So, to answer the question, is the loss high or low? So the loss for my random forest is incredibly low compared to the baseline linear regression. To reduce this further in real-world scenarios, I could acquire more localized soil quality data or utilize deep learning architecture instead of additional trees. Yes, there are parameters. For the random forest, I can tune in n estimators, the number of trees, and max depth, how the trees grow, using grid search to further optimize performance and prevent overfitting. So what happens if I get like new data? So well, my API actually has a retrain endpoint here, as you can see, the retrain here. And in a real world deployment, when a new data is uploaded, this endpoint is triggered to ping a background task that appends the new data to the dataset database, refits the random forest and label encoders, and dynamically hot swaps the new .pkl files into the memory without taking the server offline. So instead of using like the generic wildcard, which opens up security vulnerabilities, I configured my core's middleware strictly. I explicitly defined my allow origins to only accept traffic from my local host loops and specific front-end deployments URLs. I also defined exact headers and restricted the method to strictly post and get. Yes, securing the API against cross-site request like forgery or any request. So this concludes the demonstration of my API deployment and mobile app integration. Thank you for watching.